In this class, you are going to study about Faraday's laws of electrolysis. But before this, let me introduce the great scientist Michael Faraday, who proposed the laws of electrolysis. Michael Faraday was an English scientist who was born on 22nd September 1791. His parents are Margaret Hastwell and James Faraday. He contributed to the study of electromagnetism and electrochemistry. His discoveries include principles of electromagnetic induction, diamagnetism, and electrolysis. He was awarded with the Royal Medal in 1835 and 1846, Copley Medal in 1832 and 1838, Rumford Medal in 1946, and Albert Medal in 1866. So with this a brief introduction, now let us study about the Faraday's first law of electrolysis. The Faraday's first law of electrolysis gives the relation between the amount of substance that is discharged at the electrode during electrolysis and the quantity of electricity passed through the electrolyte. Okay, and the law states that the amount of substance discharged at the electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Okay, so if M is the amount of substance and Q is the quantity of electricity passed through the electrolyte, then we can put that in the mathematical form in this way. So M proportional to Q. M proportional to Q. M is the amount of substance and Q is the quantity of electricity that is passed through the electrolyte. Okay. Now here the direct proportionality is converted into equation. So for converting that into equation, we have to multiply with a constant. So here Z is the proportionality constant. Okay. So M will become equal to Z into Q. So the relation is converted into equation by multiplying with the proportionality constant Z. So here Z is the proportionality constant known as the electrochemical equivalent of the substance. In short, it is abbreviated as ECE. ECE stands for electrochemical equivalent of the substance. Okay. So Faraday's first law gives the relation between amount of substance that is discharged at the electrode during electrolysis of an electrolyte and the quantity of electricity that is passed through the electrolyte. Okay. But here we have to know that Q equal to I into T. Q is the quantity of electricity that is equal to I into T, where I is the current in amperes and T is the time in seconds. So if we multiply the current with the time, that gives the quantity of electricity. So where I is the current in amperes and T is the time in second, then Q will be equal to the quantity of electricity expressed in terms of coulomb. Q is the quantity of electricity which is expressed in coulombs. Okay. So M equal to Z into I into T. Okay. So according to equation 1, M is equal to Z into Q, and according to equation 2, Q equal to I into T. So if we substitute Q from equation 2 in equation 1, then we will get M is equal to Z into I into T. Okay. So if 1 ampere of current is passed through the conductor for 1 second, then quantity of electricity is said to be 1 coulomb. Okay. So here if you pass 1 ampere of current, so here I is the current in ampere. If you pass 1 ampere of current through the electrode for 1 second, that is T is 1 second and I is 1 ampere. So 1 ampere into 1 second, that will be equal to 1 coulomb. 1 ampere into 1 second is equal to 1 coulomb. Okay. Now we shall define the electrochemical equivalent of the substance Z. So we know that according to Faraday's the first law of electrolysis, M equal to Z into I into T. So passing 1 ampere of current for 1 second gives 1 coulomb. Passing 1 ampere of current for 1 second gives 1 coulomb. So 1 coulomb is equal to 1 ampere into 1 second. 1 coulomb equal to 1 ampere into 1 second. So substitute this 1 ampere and 1 second in this equation. So M equal to Z into 1 ampere into 1 second. So Z into 1 is nothing but Z. So M equal to Z. M is the amount of substance discharged at the electrode during electrolysis, and Z is the electrochemical equivalent of the substance. So M will be equal to Z when current is 1 ampere and time is 1 second. So if you pass 1 ampere of current for 1 second, then whatever substance is discharged at the electrode, that itself is nothing but electrochemical equivalent of substance. M itself is Z when I equal to 1 ampere and T equal to 1 second. So what is electrochemical equivalent of substance? Electrochemical equivalent of substance Z is nothing but the amount of substance discharged at the electrode when 1 ampere of current is passed through the electrolyte for 1 second. Okay. Now let us go ahead. Therefore, electrochemical equivalent of substance Z is defined as the amount of substance discharged at the electrode during electrolysis when 1 ampere of current is passed through the electrolyte for 1 second. Okay. This is how we define the electrochemical equivalent of substance. This may be asked for 1 more questions. Define electrochemical equivalent of substance. You have read this definition. Okay. Even the statement of Faraday's first law may also be asked. State Faraday's first law. Okay. So that will be for 1 mark. Statement of the Faraday's law is for 1 mark, and definition of the electrochemical equivalent of substance can also be asked for 1 mark. Or sometimes they may ask what is 1 coulomb. So 1 coulomb is the quantity of electricity when 1 ampere of current is passed through the electrolyte for 1 second. That way you have to define the coulomb. 1 coulomb equal to 1 ampere into 1 second. Okay. Now consider the electrolysis of Az plus solution, that is silver salt solution. So silver salt solution contain Az plus ion. Okay. So this Az plus will be discharged at the cathode. You know that Az plus is the cation. So cation will be attracted towards cathode, and when it goes to cathode, 1 mole of silver ion will gain 1 mole of electron to deposit 1 mole of silver. 1 mole of silver ions gain 1 mole of electron and deposit 1 mole of silver at the cathode. Okay. So 1 mole of Az plus requires 1 mole of electron to form 1 mole of silver. Is that clear? Now let us find what is the charge of 1 mole of electron. Okay. Let us find charge of the 1 mole of electron. But here charge of 1 electron is equal to 1.6022 into 10 power of minus 19 coulomb. This is the charge of 1 electron. 1.6022 into 10 power of minus 19 coulomb. Okay. And you know that 1 mole of any substance contains Avogadro number of the particles. Okay. Now if you take 1 mole of electron, so 1 mole of electron also contains Avogadro number of the electrons. Avogadro number is 6.022 into 10 power of 23. So this, you are already familiar with this Avogadro number that we have discussed in the previous videos while discussing the mole concept. Okay. So you can see the video on the concept of mole. So charge of 1 mole of electron is obtained by multiplying charge of 1 electron with Avogadro number of electrons. Okay. So charge of 1 electron is 1.6022 into 10 power of minus 19. So this is multiplied with the Avogadro number of electron, that is 6.022 into 10 power of 23. So when you multiply this charge of 1 electron with Avogadro number, that will give the charge of 1 mole of electron, that is equal to 96,485 coulombs. So charge of 1 mole of electron is 96,485 coulombs. Okay. And this charge of 1 mole of electron is called 1 Faraday. Okay. So charge of 1 mole of electron is called 1 Faraday and it is denoted as F. Faraday is denoted as F. Therefore 1 Faraday is equal to 96,485 coulombs and approximately it is equal to 96,500 coulombs. So here this 96,485 coulombs is rounded up to 96,500 coulombs. So generally we consider 1 Faraday equal to 96,500 coulombs. Okay. Now consider the electrolysis of a magnesium salt solution, that is Mg2 plus salt solution. So magnesium salt contains Mg2 plus ion and this ion will be produced in the solution of the magnesium salt, and this magnesium ion is once again a cation that will be attracted towards cathode and it will be discharged at the cathode. So at the cathode 1 mole of Mg2 plus ions will gain 2 moles of electron and deposit 1 mole of magnesium. 1 mole of magnesium ion gain 2 moles of electron and deposit 1 mole of magnesium. Okay. So 1 mole of magnesium ion is required 2 moles of electron to form 1 mole of magnesium. Okay. Now what we have to do? We have to find out the charge of 2 moles of electron, because here 2 moles of electrons are gained by 1 mole of magnesium ions. Okay. So we have to find out charge of 2 moles of electron. So charge of 2 moles of electron is obtained by multiplying charge of 1 mole of electron with 2. If you multiply the charge of 1 mole of electron, so charge of 1 mole of electron is nothing but 1 Faraday. 1 Faraday is nothing but 96,500 coulombs. So if you multiply the charge of 1 mole of electron, that is 96,500 coulombs, with 2, then you will get charge of 2 moles of electron in terms of coulomb. Okay, so this will be in coulomb. So 2 into 96,500 coulombs. 2 into charge of 1 mole of electron will be equal to charge of 2 moles of electron, that is 1,93,000 coulombs. Okay, so 1,93,000 coulomb of charge is required to form 1 mole of magnesium at the cathode. Okay, so this will be observed in the electrolysis of magnesium salt solution. Okay, so when we are electrolyzing magnesium salt solution, 1,93,000 coulombs of charge will be required to form 1 mole of magnesium at the cathode. Now consider the electrolysis of Al3 plus salt solution. So Al3 plus salt solution is the aluminum salt solution that contains Al3 plus ion. And this Al3 plus ion is a cation. Once again it is attracted towards cathode, and at the cathode this aluminum ion will be discharged to form 1 mole of aluminum. So 1 mole of Al3 plus ion will gain 3 moles of electron to deposit 1 mole of aluminum at the cathode. And here once again, here we must find out the charge of 3 moles of electron. So 1 mole of Al3 plus ion requires 3 moles of electron to form 1 mole of aluminum. So charge of 3 moles of electron will be obtained by multiplying 3 with the charge of 1 mole of electron, that is equal to 3F. So you know that 1 Faraday is equal to 96,500 coulombs. So if you multiply this with 3, so you will get 2,89,500 coulombs. So charge of 3 moles of electron will be equal to 3 Faraday, or that is equal to 3 into 96,500 coulombs, that is equal to 2,89,500 coulombs. So 2,89,500 coulombs of charge is required to form 1 mole of aluminum at the cathode. Okay. Now in general, let us consider electrolysis of the Mn plus salt solution. So here Mn plus salt solution contains Mn plus ion. So Mn plus ion is the cation. Suppose the M is the metal, then the metal will lose n number of electrons and form Mn plus ion, and this Mn plus ion will be present in the solution of the metal salt, and this Mn plus ion, once again it is a cation, it will be attracted towards cathode, and at the cathode this Mn plus ion gains n number of electrons to deposit 1 mole of the metal. Okay. So the quantity of charge required to discharge Mn plus ion will be equal to N into F. So this is the generalized formula that you can remember to find the charge required to discharge Mn plus ion at the cathode. That will be equal to N into F or N Faraday. So if we convert that into coulombs, so that will be 96,500 into N coulombs. So because 1 Faraday equal to 96,500 coulombs, so N is multiplied with the 96,500 coulombs, then you will get 96,500 into N coulombs. Now let us work out this problem. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited at the cathode? Molar mass of copper is equal to 63.5 gram per mole. So this type of problem will be asked based on the Faraday's first law of electrolysis. So in this problem, a solution of copper sulfate, that is cupric sulfate, is electrolyzed for 10 minutes by passing a current of 1.5 amperes. And here we are required to find out the mass of copper deposited at the cathode. And you know that copper sulfate solution, that is cupric sulfate solution, contains Cu2 plus ion and SO4 2 minus ion. Okay. And here it is given that current I is equal to 1.5 ampere and time t equal to 10 minutes. That should be converted into seconds. So 10 into 60 will give 600 seconds. Okay. And we know that Q equal to I into T. Now this cupric sulfate solution ionizes in solution to give Cu2 plus ion and SO4 2 minus ion. Okay. And this Cu2 plus ion, being cation, will be attracted towards cathode, and at the cathode this Cu2 plus ion will gain 2 moles of electron to form 1 mole of copper. Okay, so this is the stoichiometric equation you have to remember for this electrolysis. Cu2 plus 2 electron gives Cu. Okay. Now you must find out the charge of 2 moles of electron. So 2 moles of electron discharge 1 mole of the cupric ions. 2 moles of electron discharge 1 mole of the cupric ions. So you know that Q equal to N into F. So you must find out the charge of 2 moles of electron. That will be obtained by multiplying the charge of 1 mole of electron with 2. So Q equal to 2 Faraday. That is 2 into F. That will be 2F. Because N equal to 2 here, N moles of electrons are gained by 1 mole of Cu2 plus ion to form 1 mole of copper. So Q equal to N into F. But F equal to 96,500 coulombs. F is 1 Faraday. So 2 into 1 Faraday will give the charge of 2 moles of electron, that is 1,93,000 coulombs. Okay. So the charge of 2 moles of electron equal to 1,93,000 coulombs. So 2 Faraday of charge deposits 63.5 gram of copper, because here in the stoichiometric equation you will know that 2 moles of electron will deposit 1 mole of copper, and the molar mass of copper is going to be 63.5 gram. So it means that 2 moles of electron will deposit 1 mole of copper, that is a 63.5 gram of copper. So this is according to the stoichiometric equation. 2 Faraday of charge deposits 63.5 gram of copper. But here you are passing 900 coulombs of electricity. Okay. So 2 Faraday is nothing but 1,93,000 coulombs. Okay. So 1,93,000 coulombs of electricity deposits 63.5 gram of copper. Therefore, 900 coulombs of electricity deposits how much of copper? So if you calculate, you will get 900 into 63.5 divided by 1,93,000 coulombs, that is equal to 0.296 gram. 0.296 gram of copper will be deposited at the cathode by passing 1.5 ampere of current for 10 minutes. Okay. So mass of copper deposited at the cathode equal to 0.296 gram.